Good day, viewers, and you are welcome to MLT channel. This is Engineer Oladipo, your host, and your amiable online tutor. Today's subject is physics, and the topic is gravitational field. You are all welcome on board. Without wasting much time, let's quickly dive into details. And today's learning goal is problem solving in gravitational field. All right, let's look at the UTME question to try. So we have the question. A planet has a mass m1 and is at a distance r1 from the Sun. A second planet has a mass m2 equal to 10 m1 and at a distance of r2 equal to r1 from the Sun. Determine the ratio of the gravitational force experienced by the planets. Options: A, 1:5, B, 2:5, C, 3:5, and D, 4:5. All right, let's find out which of the options is correct. All right, so we have the same question here. Let's quickly look at the vital information in the question. So the question, a planet has a mass m1. So we have a planet and the mass of the planet is given as m1 and is at a distance. So the distance of the planet from the Sun is actually r1. Okay, so we are comparing the planet and the Sun. Okay, let's put that in diagram. Let's get our Sun. Okay, I think we can manage to use yellow to represent Sun. I need a shape. Good. Let me change the color. Okay, let's use this. I think this looks like a Sun. All right, that's cool. Then let's use it to produce the second planet. Let's change the color. Let's assume this is our own planet Earth. Let's give it maybe green color. Okay, I think that's okay too. Then let's draw a line to represent the distance between the Sun and our planet. Let's put this here because of space. Okay, that's okay. That's cool. Okay, let's name them. We have the Sun. So here is our Sun. Then we have the first planet. Let's name that first planet. Okay, that's good. Awesome. So here's our first planet. So we are done with the first sentence in the question. So let's proceed. So a second planet. So we still have another planet again. Has a mass m2 equal to 10 m1. So this second planet now, its mass is m2 and is equal to 10 of m1. Okay, let's get a solid shape again to draw the second, to represent the second planet. But m2 is equal to 10 m1. That means this planet is bigger than our planet. Okay, let's change the color. Can we give that what color should we give that? Maybe we should give that brown. Okay, that's cool. Then let's get the distance between the planet and the Sun. Okay, let's use a line to represent that. Okay, that's perfect. All right, let's proceed. So the second planet has a mass m2 equals to 10 m1, and at a distance of the distance of the second planet is r2 and is equals to 2 of r1. All right, let's label that as well. Let's label our second planet. Perfect. Let's bring that here is our second planet. So let's get their masses. The mass of the first planet, that is M1. Okay, mass of the small letter M, M1. Let's enlarge that a little bit more. Okay, that's great. Let's put that here. That's the mass of the first planet. Then it has a radius R1. Okay, let's put down its radius as well. The radius is R1. Okay, perfect. Oh, okay. The radius is not even supposed to be here. Okay, we are supposed to have the radius here. That's the distance between the sun and the planet, R1. Okay, that's okay. Then let's get the mass of the second planet. And what's the mass of the second planet given the question? That is M2. Second planet is given as M2. And that is equal to 10 of M1. Okay, that's cool. Let's change their colors to make it more visible. All right, that's perfect. Let's change the color of the mass M1 too to make it more visible. Good, that's great. Then remain the distance between the sun and the second planet. And that's given by R2. And that's equal to 10 of, that's equals to 2 of R1. Okay, that's good. So we have the two planets now. We have the first planet whose mass is M1 and the distance R1 away from the sun. And we have the second planet whose mass is M2 and distance R2 away from the sun. Okay, that's perfect. So what's now the problem? Let's proceed. Determine the ratio of the gravitational force. Okay, we want to know the ratio. Please, the word already, ratio is very important. Experience, ratio of the gravitational experience by the planet. Okay, let's represent that with a symbol. We have F1 ratio F2. Let's enlarge that a little bit more. That's good. And that is unknown. That's actually what we are looking for. Equal to unknown. Okay, that's perfect. So this is the task at hand. Although the question do not really specify this F1 ratio F2 because they just say the ratio of the gravitational forces. Then, or it could be F2 ratio F1. So regardless of the one that it is, that won't be a problem because we know that F1 ratio F2 will be reciprocal of F2 ratio F1. This is what I'm trying to say. This shouldn't be a problem because at the end of the day, we have one to be reciprocal of the other. All right, let's keep this here. Now, Let's now start solving the problem mathematically. All right, good. To solve mathematically, the formula we are going to adopt, because we are looking for gravitational force. And according to Isaac Newton, the force of attraction or repulsion between two bodies of masses m1 and m2 is directly proportional to the product of their masses and inversely proportional to the square of their distance apart. So that implies that the formula we are going to adopt here is equals to F is equals to G m1 m2 over r squared. This is the formula we shall be using to simplify this problem. Now, since we are comparing two planets, so for the first planet now, let's make that to be F1. So for the first planet. And that will be equal to G m1 m2 over r squared. So now let's now ask ourselves, what's the value of our m1? The first planet, its m1 is still given as m1. So that implies that the mass of the first planet is equals to m1. Okay. The m1 of the first planet is equals to m1 as given in the question. Then what will be the m2 of the first planet? The m2 of the first planet will actually be the mass of the sun, because we are comparing, the question is comparing the distance between the sun and another planet. So m2 will be the mass of the sun. And let's make the mass of the sun, let's represent that by ms. Okay, that's good. There is not the distance, which is r, between the sun and the first planet is r1. So that means that r equals to r1. Now substituting all these values now into the equation of our first planet. So we substitute, then we have F1, which is the force of attraction on the first planet, equals to, then the mass of the first planet, we have declared it to be m1 multiplied by m2, that is the mass of the sun, and we have declared that to be equal to ms, and the distance between the sun and the first planet is actually represented by r1. So let's call this equation 1. All right. Now, going to the second planet. So for the second planet now, let's represent that by F2. And the formula again will be formula of force of attraction as discovered by Newton, will be G m1 m2 over r squared. Then in this case, the mass of this planet is m2, which is actually the m1 in this formula. That means the m1, which is the mass of the second planet, is equals to m2. I mean the mass, it is m1 because of the formula, not the m1 of the first planet. And in the second planet, the m1 is the mass of the second planet, which is actually m2. I hope that is clear. Then m2 now, for this second planet, will be the mass of the sun, because we are considering the distance between the mass of the sun and the mass of the second planet. So, and we have already declared our second mass of the second planet to be equals to ms. And finally, the radius of this between the second planet and the sun is actually r2. Now, substituting these values into this equation now, we still have g. Okay, that was a mistake. G was omitted in equation 1. Let me quickly add that before I escape my mind again. So G is supposed to be here, and this is our equation 1. All right, so G. Then our M1 in what's it called? In the second planet is actually M2. And according to the question, M2 is equals to 10 M1. So that means this will be 10 M1. And our M2 is actually the mass of the sun, which we have declared as ms. That will be ms over. Then the radius now, the radius, that is the distance between the sun and the second planet, is actually 2r1. So that will be 2r1. But we are going to square it because our radius is squared in the formula. Okay, that's perfect. Let's call this equation 2. Now we are almost there because this is actually what we are looking for. We are looking for the ratio of f1 to that of f2. Now, substituting our equation 1 and equation 2 into this ratio, look at our f1. This is the whole of our f1. So now, bringing that now, definitely we have m1 ms multiplied by g over r1. Then ratio means divided by, then divided by what? This is, we have already derived expression for f2, and then here is the value of f2. So precisely we are substituting this value for f2. So bringing that now, so we have g 10 m1, then ms over, then if you square this, that will give us 4r1 squared. Now we just need to perform simple arithmetic here, and in doing that, that implies that our f1 ratio f2 will now be equal to m1 ms g over r1. Then this division, we turn it to multiplication, and as a result of that, the numerator now becomes the denominator, while the denominator becomes the numerator. That means we have 4r1 all squared over g 10 m1 ms. So our problem is almost solved. We can now see that there are common factors like m1 will cancel m1, ms will cancel ms, g will cancel g, then r1, okay, This is supposed to be squared. There's a square on that R1 that I've omitted mistakenly because they're supposed to be squared here. Okay, let me quickly put that. As you can see it in the formula here, there is squared on the distance radius, but I forgot to put it here. So there is squared here. Okay, so there is squared here. So there is squared here. So, and as a result of that, that will make R1 squared to also cancel R1 squared. So we are left with 4/10. Okay, so we are almost there. So that implies that our F1 ratio F2 is actually equal to 4/10. Then 4/10, there's a common factor here, which is 2. 4 here, 2 here equals to 2. Then 2 here equal to 5. So therefore, our F1 ratio F2 is equals to 2/5. And conversely, since we have already declared that F1 ratio F2 is equals to 1/F2 ratio F1, that implies that F2 ratio F1 will be equal to 5/2. So anyone that we have in the option will definitely be our correct answer, because the question do not really specify the one that should be as numerator or denominator. Just say that the ratio. Question easily done. Now let's now go back to the question to verify the answer. Okay, we have 1/5, option B 2/5, option C 3/5, and option D 4/5. Okay, let's check the answer. Show answer. All right, so we can see here that the correct answer is option B, which is actually 2/5. And let's check, is that what we get? All right, that was our answer. So question, that was our answer, and question easily done. All right, 23 minutes just gone now, like 23 seconds. It's been so fun, so engaging, and so exciting. I hope you have gained one or two things in today's class. If yes, don't hesitate to join us in the next class for another video lecture. And you can register to our physical and online classes. We are at Omega Building, opposite Gasla Nigeria Limited, Obafemi Awolowo Way, Malete, Ibadan. You can contact me. Here is my WhatsApp number. Here are my WhatsApp numbers: 08067076871 and 09155684169. You can watch more of our video lectures on YouTube, and our handle is at oladekolalekan2262. Also, we have our videos on TikTok, and our handle is tiktok.com@MLT Tutors. At MLT Tutors, we are rooted in sound values, driven by academic excellence, building the future through qualitative learning and digital literacy. Until I come your way again, I remain my humble self, Engineer Oladipo, your host and your amiable online tutor. Please kindly assist us by liking and sharing this video. Subscribe to our YouTube channel as well. Bye for now, and thank you very much for watching.